Hi, this video is going to be for exercise 1, part 2. This is the hash map array list Java portion of our exercise. We were going to javapoint.com and then review some sections on the page first, and then copy some code over into Eclipse and run some methods and then talk about them. So we'll go ahead and get started with the javapoint.com section. Starting with points to remember on hash maps. In my opinion, probably the two most important points about hash maps are hash maps contain values based on the key, and then hash maps contain only unique keys. So if you were to duplicate a key, it's going to basically override the last version of whatever value you had in place on that same key value, which I'll go over once we get into some code. As far as hierarchy, you look at this chart right here. It's pretty self-explanatory that hash map extends abstract map, and that implements map. We can also see the declaration here on how the hierarchy works. As far as parameters go, they have the generics K and V, K being the key that's maintained by the map, and V being the type of mapped values. I'll go ahead and get right into the Eclipse portion now. So what I had done is I just copy and pasted everything into their own methods as instructed here. I also just made a print line fill just to make everything look a little nicer and, split everything off, makes it easier to read. And then ran everything out of the main method by method call as requested also. So we'll go ahead and start with the hash map example. And we can see I did play with it a little bit as far as the order of putting in the key, because they just had it going 1, 2, 3, 4 as they were putting them in. I did 1, 4, 3, 2 just to prove a point. So on this particular hash map, the key is an integer, and the value type on this is a string. And we can see that's exactly what we have. We have an integer and then a string. So I did 1, 4, 3, 2, like I said a minute ago. But when it prints it out, it goes in order on the key number. And we can see we get it in order 1, 2, 3, 4. The next one is no duplicate. So I kind of monkey with this one a little bit too. So we have 1 being a mango, and then they put number 2 as an apple, number 3 as a banana, and then they had number 2 as grapes on the example on the website. Just for the point, I added another number 2, which is Lilikoi. And what we can see happened is Lilikoi, since it was the last string under that map, or that key, it overrode the last iteration of that mapped item under that key. So when apple was put into place, it was unique by itself. When grape was added with the same key number, it overrode apple. And then when Lilikoi was put into key 2, it overrode grape. Hence why we have a printing out of Lilikoi in number 2. Which is kind of neat. Next one is add elements. So we can see the initial list is blank, and then the put method, we have a key of 100, 101, and 102 with 3 names, Amit, Vijay, and Rahul. And then the next is the put if absent method. So we will add 103 and Gaurav if it's not already in the list, which it wasn't in the list. So I will go ahead and do this for the sake of seeing what happens. And we can see that Billy was already in the first ad. So since 103 was already taken, Gaurav was not added because it already existed. But if we were to take Billy out of the initial loading of the list, since there is no 103, we can see that it indeed will write it. We'll go ahead and put it. And the next one is using the put all. So from what I can tell, is it's adding 104, which is Ravi, and then the put all is basically adding the entire HM list back again. So we have 100 through 104, just like we should. And then we have remove elements. So when the list was coded, initially it had 4 values, keys 100 through 103 with 4 names. And then we remove 2 items by the key only. So 100 first, and then second was 102. Or, sorry, 100 and then 101 got removed. And then the last remove was 102 Rahul. So they went ahead and called it out completely, rather than just by the key number. And that left us with 103 Gaurav. Then we have replace elements. We can see we start off with 3 names on the list, keys 100 through 102. Amit, Vijay, Rahul. The next one, we want to replace 102 with the name Gaurav. We can see it did, in fact, replace over. On the third one, we want to replace 101. They go ahead and put 2 names in. They have Vijay and Ravi. So just like the no duplicate entry, it chooses the most recent string value to go in. In this case, Ravi would be the most recent string value. I'm guessing because it's closest to the end of the line of code on that one. I really don't have a better explanation on that one, but I'm, fairly certain that's the reason why. And then on the last one, we have a replace all, where I guess this is like a lambda-ish. So we call out the generic K and V, and since we already lambdas will already know, it will infer what value we're wanting to replace. It sees a string, it knows that the V value is a string, so it's going to go ahead and replace the strings. And we did replace all. So what it's going to do is going to keep the 3 key codes the same at 100, 101, and 102, and then just override the string name to AJ, which is the name that they had put in there. That was really it. So that was kind of a neat one to learn as far as how those work. I can see why they could be useful in certain aspects, and I can also see why in certain situations you wouldn't necessarily want to use it. But in situations where you don't want duplicate information, this would be like a good thing to use. But that's it for now, and until next time, ahoy ho.